All right, so this is part 2. Now we're going to evaluate an integral using the fundamental theorem of calculus that requires U-substitution. So I'm going to be doing C and D in this video. And note, this video is actually not a tutorial of how to do this, but it's actually just solving problems. So at this point, I'm assuming that you guys already know how to do this, but you just want to see the problems worked out. So here when I look at this problem, I need to find the antiderivative of this. But looking at this, I cannot find the antiderivative as is. And this is where I need to use substitution. So substitution is where you want to substitute the difficult part of this problem to make it look easier for you so that you can find the antiderivative. So here I'm going to let u, so the substitution, I'm going to let u equal to, so the difficult part of this problem is that exponent there that makes it kind of difficult. So I get 1 over x cubed. Or in other words, you could write this as x to the negative 3. All right, after you do the u substitution, or after you let u equal to this, now you are going to find the derivative of this. Well, the derivative of this, du over with respect to x, derivative of this is I multiply the negative 3 in front and I subtract the exponent, subtract 1 from the exponent. So here, in other words, I'm going to have du, if I multiply the dx to the other side, I end up getting this. And if I want to isolate my dx, so if I want to solve for dx then is equal to, I move this under here, I end up getting du multiplied by negative 1 over 3, and then this x to the negative 4th could go underneath here. But let's just make this look pretty. I'm going to say dx is equal to negative x to the 4th over 3 du. Because the x to the negative 4 could be on top, right, since it's a negative exponent. Okay, so the reason why I do this is because now I'm going to substitute, hence the word substitution. I'm going to substitute this u and this dx into these parts here so that everything is going to be in terms of u. So as a result, I end up getting, so this is all my side work here. So as a result, I'm going to have the integral of e to the u, because 1 over x cubed now becomes u, right? U equals to this. I have x to the 4th on the bottom. What is dx? Well, dx is this. So dx is now, so multiplied by negative x to the 4th over 3 du. So what you're going to see happen here is that the x to the 4th are going to now be reduced to negative 1. So we are left with the integral of negative 1/3 e to the u du. Now everything is in terms of u, and this is so much easier to find the antiderivative of. And notice there was a limit, or there were bounds of 1 to 2. Instead of putting 1 to 2, I'm going to put a star and a double star. So it depends on how your teacher had taught it, but the way that I teach it is I put star and double star to remind myself that even though this is all in terms of u, I'm going to have to change this back to x and use the bounds of 1 to 2 for x. So I'm going to put star and double star just to remind myself that I need to change everything back in terms of x. All right, so now when I take the antiderivative, I get negative 1/3 e to the u, and this goes from star to double star. And remember, my problem is in terms of x. So now I'm going to resubstitute everything back in terms of x. I get negative 1/3 e to the, instead of u, I get 1 over x cubed now. I replace it back to its original form. And now I could use the bounds of 1 to 2 because now we're back in terms of x. Okay, at this point, I'm going to use the fundamental theorem of calculus to solve this. So I have this equals to bracket minus bracket. So f of 2 minus f of 1. So when I plug this in, I get negative 1/3 e to the 1 over, if I plug 2 cubed here, I end up get 1/8. Minus, I have a negative 1/3 e to the, if I plug 1 in here, I just get e to the 1 power. So let's go ahead and simplify this to make this look nice and pretty. I get negative 1/3 e to the 1/8 plus 1/3 e. And if you want, you could factor out the greatest common factor. So if you want this to look like the answer that was on the test, where I wrote it like this, you could factor out the negative 1/3. If I factor out the negative 1/3, inside I have e to the 1/8, which could be written as e to the, I could write this as the 8th root of e. You don't have to, but just saying you could write it in either form. And then here, minus e, so that you could get a positive 1/3 right there. So if you want it to look like this to match the answer key, this is how you do it. Or even if you left your answer like this, I would accept that as well.